Hello everyone, my name is Shyam Manawat and I welcome all of you once again in the series of inequalities. This is lecture number 3. In the previous lectures, we have understood how to simplify the linear inequalities with one variable. In today's lecture, we are going to discuss about modulus inequalities. So let's get started. Here we have question number 1 for us. I'm sure you must have gone through my previous this previous chapter modulus, and you are well versed of the modulus sign. If you remember, when we remove the modulus sign, we take a positive sign and a negative sign. When we take the positive sign after removing the modulus sign, so we get this like 2x minus 5 more than 3. With the negative sign, I have minus of 2x minus 5 more than 3. Now, simplify this one, you get 2x more than 3 plus 5, 8, you get x is more than 4. Yeah, here if you open the bracket, you have minus 2x plus 5 more than 3 as it is. You can change the side of minus 2x here. So you get plus 2x, and here if you take this 3 here, you get 5 minus 3, that is 2. So x is less than 1 if you simplify. Yeah, you can do this way, or you can solve it by just multiplying negative sign in both the side. If you want to get rid of this negative sign, then you can multiply the minus 1 to both the side, and you can get what? 2x minus 5, 3. And if you remember, when you multiply or divide by negative sign, the sign of inequality changes, right? So it will become less than, instead of greater than, this will become less than with minus sign. Yes. So what did we do? To get rid of this negative sign here, we multiplied by the minus 1 to both sides, and we got minus, we get rid of minus here to the left hand side, and 3 will become minus 3. Now because we multiplied by the minus sign, the sign of inequality, instead of greater than, it has become less than. Is that clear? You can also do this. Yeah, if you're comfortable with the first method, go ahead with that. I'm just showing you variation so that you be comfortable. Yeah. So now here you got 2x here, and then minus 5 will go to the other side. Minus 3 plus 5 will become plus 2, and then x is less than, cancel 2, you got x is less than 1. So conclusion will be same. There will not be any difference in the conclusion. Understand? It's maths. If you are using the right approach, no matter if the approaches are different, answer will remain same. Yeah. So we got x is less than 1, and here we got x is more than 4. Now tell me, on the number line, if I try to plot the conclusion here, what do we have? We have x is less than 1 and x is more than 4, right? And I hope you understand that you won't be able to find any common value of x which satisfy both the condition. In this case, okay, this case is different from the previous lecture. In previous lecture, we had multiple equations, multiple inequalities, and question said find the common solution. In this case, it's just modulus, and we need to see the range, the values of different values of x which can satisfy this inequalities. So I hope you understood. Removing the modulus sign, you got these two options. Now if you look at on the number line, you will not have any common solution for these two. So how do you write the answer? Look at this. How do you write the answer? So you write the answer as x is less than 1 or x is more than 4. Okay, because we do not have any common solution, then that's why we are using or. Let's take a hypothetical situation. Yeah, this is the answer for this question, and if you want to write this in form of the bracket, the range, if you want to represent this in form of the set or brackets, so how will you write? X belongs to both. Now see, here in both cases we do not have equal sign, right? So for both of them it will be open bracket. So how do we represent this? From minus infinite to 1. Yeah, see this part, minus infinite to 1, it will go till minus infinite, right? So from minus infinite to 1, union. Wherever we have or, we use what? Union. This we have seen in lecture number 1 of inequality. And or here, then again we have open bracket for 4, comma, it will go till plus infinite, right? So you can see the answer in this way or this way, both of them are correct. Now, what I was trying to say here, take an hypothetical situation that by solving these two modulus, if you remove the sign of modulus and by solving these two signs, you get answer like, okay, hypothetically, if you get the answer like x is less than 4 from one side and you got x more than 1 from the other side. Now, if you look at this on the number line 0, 1, 2, 3, 4, yeah, so x is more than 1 and x is less than 4. Now, in such case you are getting a common solution, yeah, common solution which is between 1 and 4. So in that case we say x is more than 1 and x is less than 4. Understand the difference here, because in modulus inequalities, here because we did not have any common solution of these two, so these two confusion, that's why we are using or. If we have the common solution, if we get the common solution, then we use what? And common. Yeah, it is this, and so we get common solution, so we have value which is true for x is more than 1 as well as x is less than 4. You getting it? Yeah. How do you represent this in terms of bracket or sets? So you say x belongs to between 1 to 4, both are open bracket because none of them are having equal sign. Yes. Okay, let me tell you one more thing, you will be surprised to know that for open bracket sometime you will find this reverse square bracket. So do not find this to be misprint. This is also correct way of representing. So sometime open bracket we use the reverse square bracket. Yeah. If you find this in the options, don't find that to be misprint. That's the solution. Well, let's see one more question here. So we got another question with modulus sign. So see, if you want, you can pause the video and try solving it by yourself. So what do we do? When we want to remove the modulus sign, we take the positive and the negative. Yeah. Then with positive, I got 3x minus 5 less than 7 as it is. With negative sign, I have minus of 3x minus 5 less than 7. Then here you got, you simplify this. 5, if you shift to the other side, it becomes 12. And here you have 3x, then you say x is less than 3 4s are 12. Simplify here. Okay, let me multiply minus 1 to both side. Yeah, so here I will have 3x minus 5 as it is, 7 will become minus 7 here, the smaller than sign will become greater than sign. Simplified further, 5 will go to the other side. Here I have 3x more than minus 7 plus 5. Minus 7 plus 5 will get you minus 2, right? Now x will be more than minus 2 by 3. Yep. So if you look at these values on number line, you try avoiding this number line all the time. Huh? This is just for me to explain you. You need to understand, if you look at these values on the number line, the first one, x is less than 4, so you will have 4 here, less than 4 is like this, minus infinite, and more than minus 2 by 3, 2 by 3 is what, 0.6, so here minus 2 by 3, 0.6, somewhere here, it will go towards this side. Yes, we got a common solution here. Do you see the common solution? Two lines, they exist in the same area, same range. So we can say in this case, I need more space to write. We can say in this case, the x is more than minus 2 by 3 and less than 4. That is your answer. Yes. In this case, we'll read like what? The conjunction, a word joining two sentences. Here it will be and, because we got a common solution here. Are you able to understand the difference between this solution and the solution we get in the first question? Yeah, it's or, nothing was common. Here it is and, because you got something common. Yeah, it is not necessary to get common area. Understand, in the previous lecture we have been asked to find the common solution, so we have to find the common area, we have to consider the common area only. Yes, all right. Okay, with this we'll go to the next question. Okay, so we got some quadratic expression here, quadratic inequality here. We have not discussed the quadratic inequality, that I am going to discuss in lecture number 5 of inequalities, quadratic inequalities here. But still, let me give you a glance of this, because we are learning modulus inequality. Here we got modulus, you remove the modulus sign, take positive, so here you got x square minus 5x less than 6, and here if you take the negative sign, you got x square minus 5x, yeah, the whole negative, less than 6. To get it out this negative sign, here I multiply minus sign both, minus 1 both sides, so I get x square minus 5x minus 6 here, and the sign of inequality will change, right? Now what do we do? Nothing, simplify that. Now, when you simplify the quadratic inequality, simplify that as the equation, as an equation, and find the roots. So here you have x square minus 5x minus 6 less than 0. Yes, simplify this. Here you got what? You need two numbers where subtraction should be 5. So it's 6 and 1. Difference is 5. You remember the shortcut to find the roots in the quadratic equation chapter which we have discussed? Yeah. So you got 6 and 1. And how do you get this minus 5 by 6 and 1? You use minus 6 and plus 1, right? So the roots should be, change the sign here. The root should be what? 6 and minus 1. Yeah, root should be here what? 6 and minus 1. They are the roots. Okay. So with this we will say, the x here, this is quadratic inequality. Yeah. Now I am going to write some answer here which might surprise you, and don't worry, I am going to discuss that in detail when we discuss only quadratic inequalities. So hold on. Yeah, so in this case we will say x is more than minus 1 and less than 6. Okay, now let's try here. Let's try this. If you remove the negative sign, what do you have here? You got, let me take this here. So it's x square minus 5x plus 6 more than 0. The two numbers which can get you product to be 6 and sum to be 5. How do you get sum to be 5? 3 plus 2, but you need minus 5 here, so you need minus 2 and minus 3. So what will be the roots in this case? The roots in this case will be Roots in this case will be plus 2 and plus 3. Alright. Now here we will say x is more than 3 or less than 2. I know this might be confusing. Why am I writing the answer like this? As I said, don't worry, we are going to discuss that into the in a lecture of inequality, where we are going to discuss only quadratic inequalities. Fine. So hold on. But did you understand, when you remove the modulus sign, you take positive, negative, simplify that, and you get two possibilities, and then you try to simplify it further. Here you got x is between 1 to -1 to 6, and with this I got x is more than 3 and less than 2. Do you want to see that on the number line? Alright, let's draw the number line here. Let's draw the number line here. You got 0, 1, 2, 3, 4, 5, 6, and here I have -1, -2. So first solution is x is between -1 to 6. X is between -1 to 6. Okay. And the second solution is x is more than 3 and or less than 2. Less than 2. Okay. Now the original equation we had, original inequality we had is this. Tell me one thing. What should be the answer? What should be the answer here? What should be the answer here? Tell me. Okay, what do we do? Let's try using some values. Okay, that way it will be easy for me to explain you. Now suppose if I take, see, if I take this -2, which is only for the blue line, which only satisfy the blue line. The blue line is for the second condition, right? So if I take -2 here, x is -2 here, x is -2 here, what will I get? -2 square, -2 square is 4, and minus of -5 into -2, that will be -10, and minus plus, so it will be +10 here. And that's how you got the modulus less than 6. Tell me one thing, you got 14 here. Is this less than 6? It's not less than 6. You getting it? This range is this part of this less than -1 not working. Let's try the white line. Let's try taking a value which is here, which is only on the white line, let's say 2.5. yeah, let's say 2.5. If I consider x equal to 2.5, then what happens? In that case, I will get 2.5 square minus 5 into 2.5. Yeah, I want to see whether this modulus is less than 6 or not. Check. Let's check. 2.5 square, if you know, that is 6.25, minus this will get you 12.5. If you subtract these two part, what you get here, difference here will be minus of 6.25 when you see inside the modulus, and without the modulus you will find this. Using the modulus you will find 6.25, and this is also not less than 6. This is also not less than 6. Yeah, we are coming to the conclusion. Now what about taking a point which is having the common, which is common between this blue and white, both of them? Remember, blue I used for the second condition and white I used for the first one. Now let me take 1 here. Let me take x is equal to 1 here. X equal to 1 here. In that case, what do we have? What do we have? X is equal to 1. Let me write the inequality first. X is equal to 1. I have 1 square, minus 5 into 1 is 5. Here you will get -4, and if you use the modulus sign you get +4, and +4 is less than 6. Yes, that's working. That's working. Yeah, and similarly you can try for 4 and 5 also. That will also work. You know what the conclusion is? When you get this quadratic inequality, and inside that if you got the modulus, after removing you got plus and minus, look at the common area of both the solution. So this common area is working. This common area is working. Yeah. So the solution here is ranging -1 to 2 and ranging 3 to 6. So the answer here should be, the answer here for the question, what is the question? Question is x square minus 5x less than 6. Here the solution is x belongs to, should I write x belongs to? Yeah, let's do this. X belongs to -1 to 2 and 3 or 3 to 6. -1 to 2 or that means union 3 to 6. Yeah. Yes. X is what? More than -1 to 2 or 3 to 6. Yeah. Only between these range the inequalities will be satisfied. In only for these range the inequality satisfies, right? Okay, so I hope this is pretty clear. What is not clear? How did I come to this conclusion and this conclusion? That I will explain later. But apart from this, once you have this conclusion, then how do you finally identify which range is going to work? Did you understand that? Yes. If yes, then cheer up, congratulations, and don't worry, we have more concepts to cover in inequality. Yeah, the next concept is variable in denominator. When you got variable in denominator, this kind of inequality, how to solve, that we are going to learn in the next lecture. Fine. So this is it in today's lecture. My name is Shah Manawat. Thank you so much for watching this video. Keep learning. I will see you in the next lecture. Till then, stay happy, stay healthy. Bye bye.